this video, we are going to discuss the May-June 2022 paper 5.1, which is probability and statistics 1 paper. Okay, so for the first question, they want us to find the number of different arrangement, right? So the arrangement will be the keyword which tell us that our steps later will involve the permutation or something with factorial, right? So arrangement of 8 letters in the word deceive, in which all the 3 E's are together and the 2 D's are together. All right, so generally they want us to arrange it in this way, where the 3E are together. Therefore, we treat them as a bundle, and we are going to treat it as one unit or maybe one object. All right, then we are having 2Ds also. We are going to bundle them together, and we also make it as one unit or one item. And the remaining letters will be C, I, and also V. All right, so first of all, we are going to arrange these 5 items here. 1, 2, 3, 4, 5. So to arrange the 5 items, generally it will be 5 factorial. So we are having 5 factorial, which is equals to 120. All right, and now we go to part number B. Okay, so for part B, they are asking us to find out the number of different arrangement again. So permutation is involved, will be involved, okay, in this calculation of the 8 letters in the word deceive, in which the E's are not all together. So the 3 E's not all together means that it can be maybe one E with another 2 E separately, all right, or it can be also the case where all the 3 E's are separated. All right, so to make the steps easier, what I will do is like I will try to find out the arrangement where all the 3 E's are together first. All right, so that means I will want to consider if all the 3 E's are together. So what's the number of ways? Okay, so when all the 3 E's are together, then I have D, D, C, I, V. So from here, you can see that we are having actually 6 items. 1, 2, 3, 4, 5, 6. All right, so to arrange these 6 items, it will be 6 factorial. All right, so now I write down all the E's are separated. Oh, sorry, are together. When all the E's are together, generally we are having 6 factorial because of the 6 items here. And from these 6 items, you can see that there are 2 identical D. Therefore, I have to divide it by 2 factorial. So to get 360. So this is the number of arrangement where all the E's are together. And then I also want to find out the arrangement without restriction. So the arrangement without restriction, which means that we are actually trying to arrange all the 8 letters. All right, so when you try to arrange all the 8 letters, we are having 8 factorial. But we are having 3 identical E and also 2 identical D in our arrangement. Therefore, I have to divide it by 3 factorial and also 2 factorial. And I will get 3360 for the arrangement without restrictions. And now to get the answer for the number of ways where the 3 E's are not all together, not all together means that I'm going to take the total arrangement minus the arrangement where all the E's are together. So minus 360. Therefore, we are having 3000 as the answer. All right, so this is how we solve question number 1. Okay, so question number 2, we have 6 men and also 8 women in a book club. And then the committee of the club consists of 5 of its members. Then Mr. and Mrs. Lan are the members of the club. All right, so in how many different ways can a committee be selected? Okay, so this is an important keyword. Selected means that we are going to choose or select, all right? Therefore, the steps later will involve combination, NCR. Okay, so selected, if exactly one of Mr. Lan or Mrs. Lan must be in the committee. Okay, so you have to think in that way. I'm having 5 members in the committee, right? Okay, so we're having 5 members in the committee. Okay, so the first case is maybe Mr. Lan is in the committee. The second case is Mrs. Lan will be in the committee, right? Okay, so if Mr. Lan is in the committee, I still need to select 4 committee members from the remaining from the remaining members in the book club. Okay, so how can I select the 4 members to become the committee? We are having 6 and 8, total 14 members in the book club, and I want to exclude Mr. and Mrs. Lan from being selected. All right, therefore, I have only 12 members left, and I want to choose 4 of them to be in the committee. At the same time, the same case also, that when the Mrs. Lan is in the committee, I want to exclude Mr. Lan from being selected. Therefore, the available number for the members will be 12 also, where I'm going to select 4 members from the remaining 12 members. All right. So for both of these separate case, I will give you the number of combination, which is 495. All right. Therefore, we need to get the total ways. So for the total ways, it will be 495 multiplied with 2. And the answer should be 990. Right, so this is how we answer part A. And now let's continue to part B. In how many different ways can a committee be selected? Again, this is the keyword that involves the combination. If Mrs. Lan must be in the committee, and there must be more women than men on the committee. So there's another restriction here. They are asking for more women than men, and Mrs. Lan must be in the committee. Okay, so maybe we can list out all the possible cases first. First case, I'm having 5 members in total in the committee, right? Okay, so Mrs. Lan must be in the committee. Okay, then must have more women than men. Therefore, I have another 2 women committee and 2 men committee. So that means for this case, you're having 3 women with 2 men. We might also have the case where Mrs. Lan in the committee, and then to have more women than men, I might have another 3 extra women in the committee and 1 man in the committee. And the third case, I might have Mrs. Lan in the committee where the remaining committee members are all women. Therefore, you're having more women than men. So all these are the possible cases that we have. Okay, so originally I'm having 6 men and also 8 women. Mrs. Lan is already in the committee, therefore I want to reduce 1, become 7 women in total. And for the men, you want to exclude Mr. Lan from being selected. Sorry, so we actually can include Mr. Lan in the selection, right? So I will just keep it as 6. All right, so now for case number 1, I want to select 2 women to be in the committee and also 2 men into the committee. So 2 women selected from 7. So 7C2 multiply with 6C2. For case number 1, I'm having 315 15 combination together committee with this combination, right? Then for case number 2, I want to select 3 women and 1 man. So 3 women and 1 man means that 7C3 multiplied with 6C1. And for the last one, I'm having 7, all the women in the committee. I have to select another 4. So 7C4 multiplied with 6C0. Okay, so after I calculate all the combination for each cases already, then I'll get the total ways. So the total ways will be, we have to add them together for all the cases, and we are having 560. All right, so this is how we solve question number 3. The times taken to travel to college by 2,500 students are summarized in the table, right? So we are having the time interval and then we are having the frequency. Okay, so for first part A, they want us to draw a histogram to represent this information. All right, so first of all, before you draw the histogram, let's have a look for the interval, time interval. All right, so the time interval provided here are already the class boundaries. Then we can directly check on the width. So for the width of the first class is actually 20. The width for the second class is actually 10. Third class also 10. Fourth class is 20. And the fifth class is 30. So from here you can see that and we can observe that the width of every single class of the classes are unequal. Therefore, we have to sketch unequal width histogram. Right, so to sketch unequal width histogram, generally we need to calculate the frequency density. So frequency density, we can get it by using frequency divided by the width. Okay, so for first class, I'm taking 440 divided by 20. Therefore, the frequency is equals to 22. That's for first class. For second class will be 720 divided by 10. And we get 72 as the frequency density. Then the same thing applies for every single classes later. So third class is 92. Fourth class is 15. And the last class is 40. Oh, sorry, is 4. All right, so after I calculate all the frequency density here, these are actually the heights for every single bar in my histogram. Okay, so we can set up the graph now. Okay, so our first value start from 0, the time interval start from 0 and end at 90. Start from 0 and at 90, so we can determine the ratio that we want to use. Right, so maybe for me, I'm using this. All right, and then because we're having 92 as the highest frequency density, right? So I'm going to use the 5 box. So my x-axis, maybe I can draw it here. Okay, and this is 0. All right, then definitely this is 20, 40, 60, 80, and 100. Okay, so the time here is actually the time taken in minutes. So time taken in minutes. Okay, so then we talk about the y-axis. So for the y-axis, we're having frequency density. Okay, so for me, I want to decide it as a ratio like this, 20 units, then 40, 60, 80, and 100. And after that, I can start plotting the graph. Okay, so for the first class, right, from 0 until 20, the frequency density is 22. So we try to measure 22 and draw the bar with the width from 0 until 20. Okay, then the next one will be 72. So 72 with the class width, okay, with the class width 10 unit, therefore my 72 will be somewhere here. So this is how my histogram look like, part of them, the first 2 bars. Okay, then for the third bar, 92. Again, the width is 10, sorry, the width is 10 units. So 10 units means here. So this is the third bar. Okay, so you try to draw it as nice as possible. All right, then the fourth bar is 15, where the width is 20 units. So 15, my 15 will be somewhere here. Okay, and then the width is 20 units, so 15. All right, and lastly, 30 units for the width, and then it is actually 4. The frequency density is a 4. So this is how my histogram look like. Alright, so you can see that we're having unequal width histogram where the calculation for frequency density is needed. Alright, then now let's continue to part B. So for part B, from the data, they want us to estimate the mean. Oh, sorry, they already tell us that the mean is 31.44. They want us to calculate the standard deviation that they use on the time taken to travel to college. Okay, so let us answer this question. Maybe I can move it up. Oh, cannot. Never mind. All right, then let's start. Okay, so to calculate the standard deviation, generally I need to have the formula, and inside the formula I need the summation of fx squared. So the summation of fx squared means that you multiply the f together with the midpoint. X will be the midpoint for each class, and we square it. As an example, for the first class, midpoint will be 0 plus 20 divided by 2. So 0 plus 20 divided by 2, you get a 10. And the frequency is 440. Therefore, I'm taking frequency 440 multiply with the midpoint. So the midpoint will be 10, and we square it. All right, and we do the same thing for the rest of the classes, the class interval. So I'm having 720 multiply with the midpoint, which is a 25 for second class. 920 multiply with 35, which is the midpoint for the third class, and so on. Okay, so please take note that the steps should include all the midpoints for every single classes. So all these are the midpoints for every single classes. And then if I try to calculate the summation of this, I'm having 3046,000. And now I will start to find out the standard deviation. So to find the standard deviation, generally the formula will be summation of x squared. Okay, so summation of x squared divided by summation of f. Okay, so I'm having summation of x squared divided by summation of f, which is 2500 minus the mean square. So it is provided that the mean is equals to 31.44, and we square it. Okay, definitely we need to take a square root, right, to get the standard deviation. And I will get 15.16332417. And after that, correct it to 3 significant figure. I'm going to have 15.2. So this is correct to 3 significant figure answer. Okay, then let's continue for part C. Okay, so for part C, they're asking in which the class interval does the upper quartile lie. Okay, so to get the upper quartile, generally we need to know what is the cumulative frequency first. All right, so we try to figure out all the cumulative frequency. Then only we can list out the class that the upper limit, the upper quartile lies. All right. Okay, so for the cumulative frequency, the first class will be 440. Second class, the cumulative frequency should be 440 plus 720. So 440 plus 720, we'll get 1160. Then for the third class, you add 920, we get 2080. Then plus another 300, 2380, and of course, after you add the last one, it will become 2500. So for upper quartile, we are going to look for the position or the location. So to get the location or position for the upper quartile, have to take 2500 multiply with 3/4. So we are going to see where is the location or the position of the upper quartile. So the upper quartile will be at this position. Okay, 1875 position. So let's have a look for the cumulative frequency. Okay, this one means that from 0, the frequency 0 until 440, it is inside the it is belongs to the class interval 0 to 20. From 441 until 1160, it is belongs to the class interval 20 to 30. And from 1161 until 2080, okay, it belongs to all the class for 30 to 40. And you can see that 1875, this position is under this column. And therefore our upper class, our upper quarter will be this class interval. All right, so you can straight away state the answer for this, where it is actually 30, x, and 40. And now for part number D. Okay, so it was later discovered that the time taken to travel to college by two students are incorrectly recorded. So you can see that incorrectly recorded data. So one student, the timer is actually 15 instead of 5. And the other time was recorded as 65 instead of 75. Okay, so let's have a look for 15 and 5 and then 65 to 75. Without doing any further calculation, they want us to state with a reason whether the estimate of the standard deviation will increase, decrease, or stay the same. All right, so originally the data should be 5, but we record it as 15. Then another one will be 75, but we record it as 65. So let's have a look for the data again. 15 and 5, right? They are belongs to the same class, 15 and 5. And then for 65 and 75, they are also belongs to the same class. So when all the data belongs to the same class, right? Generally, the midpoint and frequency will not change. And therefore, the standard deviation calculation is still the same like what we did just now, and it will stay the same. So you can write in this way, the standard deviation actually stay the same. And what is the reason? The reason is because of the data are in the same interval. So when the data is in the same class interval, right? Generally, when you want to calculate the probability, the standard deviation, using the midpoint and also using the frequency, still the same. All right. Therefore, the final answer for standard deviation will be the same. Okay. So this is how we solve question number. Okay. Then question number 4. Jacob has 4 coins, and then one of the coins is biased, such as when it is thrown, the probability of obtaining a head is 7 over 10. The other 3 coins are fair. So Jacob throws all the 4 coins once. The number of heads that he obtains, denoted by the random variable x. The probability distribution table for the x is as follows. So this is what we have for the probability distribution. First, they want us to show that a equals to 1 over 5. And after that, we need to find out the values for B and also the C. All right, so for A, the probability A, all right, it is when the x is equals to 1. So x equals to 1 means that you obtain 1 head and 3 tails. Therefore, if I want to calculate the probability for A, I need to discover and try to figure out how many cases do I have for x equals to 1, where 1 means that you are having 1 head and 3 tails. Okay, so first of all, I might have the head appear on the buyer's coin, and all the other 3 fair coin are tails. This is the first case where if you read the result, you can see that we are having 1 head. We are obtaining 1 head when throw all the 4 coins. For the second case that we have, we might have the head. We might have the head actually is from the fair coin, and the other 3 tails, one of them are from the buyer's coin, the other 2 are from the fair coin. Okay, so besides the second coin will give you a head, it might also have the third case where this third coin having the head and also the last coin having the head. So you can see that for all this, right, all the head appears in the fair coins. All the buyer's coin get the tail. Therefore, when you want to calculate this particular probability for all the three cases, they should be the same. Therefore, to save the time, we should just straight away put it as multiply 3 lah, because we're having three possible cases. Okay, then now we try to find out the probability for every single case here. To get a head on the buyer's coin, the probability is 7/10. To get the tail at the fair coin, the probability is 1/2. And you're having three coins, therefore it should be 1/2, 1/2, and 1/2. Or you can write it become 1/2 power 3. And for this case, to get the tail on the buyer's coin, it will be 3/10. To get the head, 1/2. To get the tail on the fair coin, 1/2, also 1/2. And I have to multiply with 3. Okay, so if I try to get the final simple result, the answer should be 1/5, where it fulfills what they want us to prove. Okay, so when the answer that I get is actually equals to what they want us to prove, right? Generally for this question, they are telling us that the method that we are using here is actually a correct method. So you can continue to use it to solve the rest of the question. All right, so they are looking for the probability of B, this one, and also the C. So B means that you're having 2 heads. C means you're having 3 heads. Number of heads equals to 3. Okay, so to calculate the probability for B, generally it means that you want to find out the number of heads which is equals to 2. So again, I will try to list out all the possible cases. Okay, so when I'm having 2 heads, it is very likely that I might have 1 head on the buyer's coin and then 1 head on the fair coin. Then the remaining 2 are tail. So again, I'm having 3 fair coins, right? So it might have the second fair coin become the head, the third fair coin become the head. Right, so you have to multiply with 3. Okay, so besides this case, I might have the head is not from the buyer's coin, but both of the heads are under the fair coin. Okay, so if we're having HHD, we might also have HDH, we might also have DHH. So you're having 3 different cases here also, 3 possibility. So you have to multiply with 3. Okay, so I think these are all the possible cases that where we are having 2 heads in total. All right, so let's calculate the probability. To get the head on the buyer's coin, it will be 7/10. Then the fair coin, okay, on fair coin, to get head tail tail, it will be 1/2 power 3. So multiply with 3. Then plus, for the second case here, to get a tail on the buyer's coin, it will be 3/10. And the remaining also 1/2 power 3. And I multiply it with 3. And now for this question, part B, the value for B will be equals to 3/8. Okay, so maybe you can tell them that, oh, this is actually the value of B. All right, and of course, don't forget about x equals to 3. So when x equals to 3 means that in total, you are having 3 heads. Okay, so to get the 3 heads, I might have one head on the buyer's coin, the other 2 on the fair coin with a T. So for this one, you might have also HDH and also DHH, where the buyer's coin is always the head. Okay, so from here you can see that they are having 3 different cases, therefore you have to multiply with 3. Okay, and after that, what are the other possible cases that we have? We might also have the case where the tail is in the buyer's coin, then all the heads are in the fair coin. So this one you don't have any other arrangement, so you just have 1, which is multiplied with 1 only. This one you have multiplied with 3 because you have other cases, right? Okay, then now I start to calculate the probability. To get a head right on the buyer's coin, it will be 7/10. Then to get anything on the fair coin, it will be 1/2 power 3, then times 3. For this one, if you are having the probability of tail on the buyer's coin, then it will be 3 over 10 multiplied with 1 over 2 and power 3. So from here, the value of C that I get is 3 over 10. Alright, so this is the value of C. End up, make a simple summary. B is equals to 3 over 8 and also C is equals to 3 over 10. And just a small checking to see whether your answer is correct or not, you try to add all the A, B, C with all the other probability together and see whether do you get a total equals to 1 or not. If you didn't get it is equals to 1 for the total, that means definitely your answer is wrong, somewhere wrong. Okay, but if you get the total which is equals to 1, then very likely your answer should be the correct one. Okay, so this is what we have for part B. Part A for question number 4. Okay, so let's have a look for part B in question number 4. Okay, they want us to find the EX. So to find the expected value for the X, you take the X multiplied with the frequency. So as an example, when X equals to 1, when X equals to 0, you multiply with 3 over 18, so you get a 0. Then when X equals to 1, you multiply with the value for A, which is 1 over 15. So you take X multiply with the probability 1 over 15. When X equals to 2, the probability is a B, which is 3 over 8. When X equals to 3, the probability is a C, which is 3 over 10, and so on. And from here, if I try to calculate the probability, it should be 11 over 5, or you can write it become 2.2. Okay, so this is what you have for part B. And now let's take a look at part C. Okay, so for part C, they said Jacobs throw all 4 coins together for 10 times. Okay, so from this 10 times, right? Okay, fewer than 3 times, something happens. Something happens means exactly 1 head. So for this structure, generally it belongs to binomial distribution. Okay, so I'm having y lah. So y maybe is the number of occasion. So you throw them for 10 times, right? And what is the probability for obtaining exactly 1 head? So obtaining exactly 1 head, it is actually 1 over 5. For the A, this is actually the A. Okay, when you get exactly 1 head, the probability is A, which is 1 over 5. Therefore, you should put 1 over 5 here. And they want us to calculate the probability where the number of time is less than 3, fewer than 3. So for binomial distribution, you can start from 0, where 10C0, y equals 0 lah. Okay, so 1 over 5 power 0, then 4 over 5 power 10. Okay, then I also need to include 10C1 when the y equals to 1, right? So 1 over 5 power 1, 4 over 5 power 9, and also 10C2. You should stop here because of in the symbol, right? It should be y less than 3, where 3 shouldn't be included. Therefore, the final term for us to have here is 10C2. And again, to get the final answer correct to 3 significant figure, it should be 0.678. Okay, so this is what we have for part number C in question number 4. And next one, let's have a look for part D. All right, so for part D, again, they want us to find the probability that Jacob obtains exactly one head for the first time. So this one, the keyword will be first time. So usually when you see the word first time, get something for first time, it will be generally a geometric distribution. And to put in the P, it should be the probability for exactly one head also, which is 1 over 5. Then they said, obtain the one head for the first time on the 7th or 8th time. So 7 or 8 time means that they want you to calculate the probability for y equals to 7 and also y equals to 8. So when y equals to 7 means that the first 6 times you are not obtaining exactly one head. So it will be q power 6 multiply with the last time you get what you want, so 1 over 5. Same thing happens for y equals to 8. For the first 7 times, when you throw the coins, right, you didn't get exactly one head in your occasion or in your experiment. All right. So first 7 times, so power 7. And the last time, the 8th time, when you throw it, finally you get the result that you want, which is exactly one head. Okay. So try to get the answer from this formula, and therefore we are having 0.0944. Okay, so this is the way how we solve question number 4. Okay, so question number 5. We are having the length of the leaf in particular type of model by the distribution of this. Okay, so this is actually normally distributed, all right, and the mean variance are given. Okay, they want us to find the probability that the randomly chosen leaf of this type has a length less than 6 cm. All right, so if let's say x denote the length for the leaf, therefore we know that it is binomial distributed. It is normally distributed with this mean and also the standard deviation and the variance. Sorry, and then we are going to find out the probability for x smaller than 6, the length less than 6 cm. So to find out the probability for this normal distribution, definitely you need to change it become z. First time you have to standardize it. So 6 minus the mean divided by standard deviation. All right, so from here I'm having the value of z, which is 0.533, and we are going to get the probability from 0.533 when the z is 0.533. Okay, so 0.5 is here, 0.53 is here, therefore our answer will be this, and then you need to add another digit at the back, so 533. So look for the 3, and what is the value that you have to add? You have to add the 10 at the last 2 digits of this value. So when you add 10 for the last 2 digits for this value, it will become 0.7029. Therefore, your answer here will be 0.7029, and you can change it become 3 significant figure where it is 0.703. So this is how we solve part A for question number 5. Okay, then now we continue to part B. So for part B, we have another type of leaf, all right, and the length also modeled by normal distribution. Okay, then a scientist measured the length of the random sample of 500 leaves of this kind and finds that 46 are less than 3 cm and also 95 are more than 8 cm long. Okay, then they want us to find the estimates for mean and also the standard deviation for the length of this type of leaf. Okay, so they didn't give us any value about the mean and standard deviation, and we want to find it out. But they provide us some information to start with. Okay, so the first information is this one, where we are having 46 of the leaf less than 3 cm long. That means if I try to write out in probability symbol, it will be the probability of x, or maybe you can put it as a y if you want, all right, smaller than 3. Okay, so when the x is smaller than 3 or less than 3, right, we are having 46 of the leaf are having this length. So 46 out of 500 will actually give us a probability, or maybe will give us a percentage or proportion. All right, so the proportion of x less than 3 should be 46 over 500. And another information that we can get is from this part. 95 of the leaf are more than 8 cm long. Therefore, if I try to write it out in the symbol form, it will be when the length greater than 8, it is equals to 95 over 500. All right. Okay, so first of all, to get the mean and standard deviation, we actually need to standardize, okay, our x first. So I want to standardize the x. It will become 3 minus the mean divided by standard deviation. And 46 over 500, the value should be 0.09. Okay, so when I try to sketch the diagram or the area for this equation, generally I'm having the area on the left hand side, which is small, 0.092, and this actually tells us that this particular value will be 3 minus 6 over standard deviation. Okay, and now we want to find out what is the value of z at this part, so that we can equate 3 minus mu over standard deviation with the z value. Alright, so if you try to look for the probability from the table, this value doesn't exist in the table. Therefore, we actually have to take 1 minus 0.092. Okay, so when you take 1 minus 0.092, we will have 0.908. So actually, this large area that I didn't shape it is the area which is 0.0908, and we can find out the value, okay, by using this probability. Okay, or you can try to convert your graph to the positive side, where if I try to sketch up the graph by using all the positive value, right, I will have actually the same area on the right, which is 0.092. And since I already changed it from negative side become positive, right, therefore this value of z will be 3, negative 3 minus mu divided by standard deviation. So either one, okay? But no matter how, when you try to change it become this kind of graph also, you still need to use the 0.908 to find out the value of z. Okay? All right, so here we need to try and figure out what's the value for z for this part. Okay, then let's have a look. How should we equate it? Okay, so let's have a look for the 0.908. So from table, try to find out the probability. All the probability exists here, and you want to find the value of z outside. So find out from here the probability and to get the value for z. All right, so my value is 0.908. We need to look for a value smaller than 908, but very close to 908. Okay, so if we have a look at 908, to me this value is actually closest to the 908, 9066, because the next value is 9082, which is already more than 908. Okay, so we are looking for 0.9066, and the value of z that I get is 1.32. So if you go on top here, this line is a line number 2, right? So 1.32, and I need to add 14 to get 908. So to add a 14 at the last two digit, this is 14 that we have. Therefore, the next value will be 9. Okay, so if you combine all the three values here, it will be 1.329. So I'll put it in our solution. So this value equals to 1.329. Okay, and I can try to form the first equation from here. I'm having 3 minus mu equals to negative 1.329 sigma. And I might want to make it like this. So the mu equals to 3 plus 1.329 sigma. And this is my first equation. Okay, and now we proceed to the second information here. So for this second information, again, the same step I need to apply is to standardize it. So 8 minus the mu divided by standard deviation. And the probability that I get should be 0.19. Okay, so if I try to figure out this diagram, the area of this diagram, right? So it should be somewhere like this. And this area is 0.19, which means that this particular value of z will be 8 minus the mu divided by standard deviation. Okay, so this is a small area. Therefore, if you want to find a small area from a table, we're not able to make it. So you have to find out the large area that is tally with this small area. So to get a large area for this graph, you take 1 minus 0.19 and you get 0.81, which means that you have to refer to the probability 0.81 to get the value of z. Okay, so let's go back to the table looking for 0.81. What is the probability less than 0.81 but very close to it? So from here, I think we should get this 0.8078. This value closest to 0.81, okay, but it is smaller than 0.81. Therefore, the value here will be 0.87, and we need to add 22 to get the 0.81. So 22 is this, and if you look further, the digit here is an 8. Okay, so again, you are having 0.878. Okay, so the value of z here will be 0.878. So I will just equate it like this. Okay, so 8 minus the mu divided by standard deviation equals to 0.878. Okay, then if I rephrase my equation, I will have 8 minus 0.878 sigma. And this will be my second equation. All right. Okay, so since we are having two equations here, and if we try to solve it simultaneously, then we will get the answer for the sigma and also the mu. Okay, so I will let equation number 1 equals to equation number 2, where we will have 3 plus 1.329 sigma equals to the second equation. Okay, then for the sigma value that I get after I rephrase everything, right, I will get 2.2655188804. And of course, I will change it become 3 significant figure where sigma equals to 2.27. Substitute the original value either into the equation number 1 or equation number 2 to get the mu. And from here, the mu that I get will be 6.01, correct to 3 significant figure. Okay, so this is how we actually form the two equations, and so that we can solve them simultaneously to get the value for standard deviation and also the mean. Okay, right, then now we continue to part C. Okay, so for part C, they are saying that in the random sample of 2000 leaf of this second type, so they are talking about this second type, how many would the scientists expect to find with the length more than one standard deviation from the mean? Okay, so to find out this probability and how many of leaf belongs to this type of length, right? So we have a look for this one first. One standard deviation from the mean. Okay, so what's the meaning for one standard deviation from the mean? Generally, if we have a number line, okay, if we have a number line and then I assume that, okay, mean maybe is somewhere on the line. So this is, let's say, the mean. One standard deviation from the mean means that it can be somewhere here, because one standard deviation above the mean, and it can be also one standard deviation below the mean, where it will become mean minus the standard deviation. So the distance here will be also one standard deviation. Okay, so this is the meaning of one standard deviation from the mean. And when they want us to calculate a probability, they are looking for more than one standard deviation from the mean, which means that the area that we want to find out, or the probability that we want to find out, will belongs to this part and also this part, because these two parts are having the distance where it is more than one standard deviation from the mean. Okay, so to calculate the probability for these two areas, you can write out in this way. So we want to find out the probability where x is smaller than mu minus standard deviation, and also the probability that x is greater than mu plus standard deviation. Okay, again, since this is a normal distribution, right, you have to change it and standardize it, become the z. All right, so this is the original value for x. So you have to minus the mean, divide by standard deviation. The same thing happened for the second part. Okay, so I'm having z greater than mu plus sigma. This is the original x. So you have to minus the mean, divide by standard deviation. Okay, so when you try to simplify all this, right, you will have the probability of z smaller than -1 and also z greater than 1. Okay, generally, if you have a look for the diagram, okay, or the area, these two areas are actually the same. These two areas are the same. Therefore, you can rewrite become 2 times of the probability of z greater than 1. In the normal table, they provide us the probability for z smaller than 1. So I want to look for greater than 1, I have to take 1 minus. Then I will look for the table. Okay, so the normal table, when z is equals to 1.0, okay, the probability that we have is 0.8413. Therefore, I have 1 minus 0.8413. Okay, so from here, I'll get 0.3174. So this is a probability, right? This is a probability where the leaf has the length more than one standard deviation from the mean. Okay, this is probability, but if you look at the question carefully, they are asking for the number of leaf. How many would the scientists expect to find the length? How many of the leaf? So they are asking for the number of leaf. We are having 2,000 leaf, and the probability is 0.3174. Therefore, to get the number of leaf, you have to take 2,000 multiply with 0.3174. Okay, so you'll get 634.8. So for us, right, we will actually treat the leaf as a whole number. So 634.8, I can change it become 635 leaves, correct to 3 significant figure. Okay, so for your information, right, the marking scheme also accept if you change the value to round down the value to 634. Both answers are accepted, either 635 or 634. Okay, so this is how we solve question number 5. Okay, so question number 6. Janice is playing the computer game. She has to complete level 1 and level 2 to finish the game. So there are 2 levels here. She's allowed at most 2 attempts. So at most 2 attempts at any level. So for level 1, the probability that Janice complete at the first attempt is 0.6. If she failed her first attempt, the probability that she complete the second attempt is 0.3. Okay, so if Janice completes level 1, she immediately moves on to level 2. So for the level 2, she complete the first attempt is 0.4. If she failed her first attempt, then the probability that she complete at the second attempt is 0.2. Alright, so I think very simple. For level 1, you have 2 attempts at most. Alright, level 2 also at most 2 attempts. But if let's say for level 1, you already successful, okay, or you already complete at the first attempt, you can straight away go to level 2. Alright, okay, so now they are asking us to show that the probability that Janice moves on to level 2, is 0.72. Okay, so how can we calculate the probability here? Okay, so what are the possibility or what are the possible cases that we have for her to move on to level 2? Okay, so first, we might have she's successful. So at level 1, she's successful straight away. So she'll move on to level 2. This is the first case. So 1 here means level 1, then S means successful. Alright, so first case is she's successful in the first level. So straight away she will move to level number 2. Okay, another possible case is for the level 1 first attempt, right? She failed. Then the second attempt she's successful. After that only she can proceed to second attempt. Alright, if let's say both fail, then you cannot proceed to second level, right? Okay, so sorry, should say second level. So now first attempt at the first level fail, but second attempt in the first level success, therefore you can move to level number 2. So these are the two cases that we have. Okay, what is the probability that she success or she complete, okay, first time at the first level? So first attempt is 0.6 at the first level. So for case number 1, you're having 0.6 straight away. And then for case number 2, the first attempt failed. So first attempt fail will be the opposite of 0.6, which is 0.4. And after that, the second attempt complete or maybe success, which is 0.3. So you're having 0.4 multiplied with 0.3. Okay, then if you try to press the calculator, then you get 0.72. Alright, so this is a warm-up question actually to let you know that you have to list out all the possible cases and plug in all the probability correctly or carefully. Alright, so if you get 0.72 means that this particular method actually works. Alright, or maybe the method is correct. Alright, okay, so you settle part A. Then now let's have a look for part B. Okay, so for part B, they want you to find the probability that Janice finishes the game. So finishes the game means that she passed level 1, she also passed level 2. Okay, so how to calculate the probability? Okay, so for first case, or maybe you can list out case by case if you want. So maybe for case number 1, right? You might have level 1 first attempt successful, level 2 first attempt also successful. So that means you finish the game. So this one means that she only play 2 games, two time. Alright, and for each attempt in level 1 and level 2, she's straight away successful. Okay, so case number 2, I might have first attempt at level 1 fail, second attempt at the level 1 success. Then the first attempt in level 2 straight away success. So this one also means that she finished the game. Okay? Yeah, so this is what we have. Then for third case, we might have first attempt for level 1 success, so she can proceed to level 2. So there's possibility that the first attempt for second level she failed, and the second attempt for second level only she success. So you're having three games here. Sorry, not to say 3 games, it should be 3 attempts here like total. Right, this also means that she finished the game. And we also have a fourth case. So for the fourth case means that I might have first attempt at level 1 fail, second attempt at the level 1 success, first attempt at the level 2 fail, and then the second attempt at level 2 success. Alright, so all the outcome here generally means that she finished the game. She successfully finished the game. Alright, so let us calculate the probability for case number 1. So case number 1, first attempt success straight away is 0.4. Second, then the first attempt at second level straight away success also 0.4. Okay, so this is the probability for first case. Second case, first attempt level 1 fail. So first attempt level 1 fail will be 0.4. second attempt at level 1 success, and it becomes 0.3. So you can slightly refer here again. Okay, so first attempt level 1 success 0.6, first attempt second level success 0.4. Okay, then now we are at this part, first attempt level 1 failed, so it will be 0.4 lah, the opposite of 0.6. Second attempt at level 1 pass. So second attempt, first level success means that it will be 0.3. And after that, first attempt at level 2 success, which is 0.4. So 0.4 times 0.3 times 0.4. And you get the probability for this case. Case number 3, first attempt level 1 success. So straight away is 0.6. First attempt level 2 failed, so it will be the opposite of 0.4, which is 0.6. Second attempt of level 2 success, so it will be 0.2. Okay, so this is a probability for the third case. And the last case, first attempt level 1 failed is 0.4. Second attempt level 1 success is 0.3. Okay, then first attempt at level 2 failed, it will become 0.6. Second attempt at the level 2 pass, it will be 0.2. So you calculate the probability for each of the cases here, and after that you will get the answer, which is 0.3744. Then of course we will change it become 3 significant figure, where it will be equals to 0.374. Okay, so this is how we solve part B. Okay, then now we proceed to part C. Okay, so for part C, they want us to calculate the probability that Janice fails exactly one attempt, given that she finished the game. Okay, so highlight the word given that. This tells us that it is a conditional probability. So for conditional probability, right, you have a slash, right? You have a slash, and then given that something happened first, we already know that she finished the game. So finish the game, we write it here. And then on the left hand side of the symbol, you need to put in fails exactly one attempt. So fail exactly one. Okay, so according to the definition for conditional probability, you need to find out the probability that Janice fails exactly one, intersect with she finished the game, divided by the probability of she finished the game. So this is actually the definition for the conditional probability, right? Okay, so how to calculate the probability that she fails exactly one, but at the same time she finished the game? Okay, so generally what you need to do is that you have to refer to all the cases that we list out here. Okay, which of these cases actually have the meaning of fails exactly one and then finish the game? Okay, so case number 1 definitely no, because she didn't fail at all. Okay, then for case number 2, I think this is what we want to consider. Okay, for case number 2, because you can see that from our outcome here, she fails once, but she still complete the game. If you have a look for case number 3, this is also the case that we want, because we only fail one time also. All right, so also fulfill the condition here where fails exactly one, intersect with finish the game. Then the fourth case, we are having 2 fails. Therefore, this is what we want to consider. All right, so I start to put in the steps where we are going to consider these 2 probability here. 0.4 multiply with 0.3 multiply with 0.4 Another case is 0.6 multiplied with 0.6 multiplied with 0.2. So divided by the probability finish the game. So if you have a look in detail, right, our part 2 just now, we already calculate the probability that she finished the game. Therefore, the finish the game probability, you can take it out from this part. It is 0.3744. Okay, and then from here, if you try to simplify everything, okay, your answer should be 25 over 78, or you can change it become 3 significant figure where it should be 0.321. Okay, so this is how we solve all the 6 questions for this partial paper. All right, so thank you very much for watching.